All right, so we looked at an example problem like this, but it was one example. So if I had, let's say, so I have one line, wee. I'm going to call this f of x. Here's wee. G of x. Okay. Right. And I ask you, okay, where is it true that f of x is less than or equal to g of x? So how do I interpret that visually? Or just in English, it means where's the f function under, not equal to, less than or equal to. So where are these beneath these? Where are these outputs less than those outputs? Or better English yet, where's that line under that line? For how long? So which one's the f function is the black line. And it's a straight line, so where does it start to be under the green line?
1, 2.
No. I mean, that's where it stops being under. That's where it stops being under. After that, it's over. So from what to there? From negative infinity. What's the only variable in this equation? X, right? I mean, if I solve this inequality, it's going to be x. I only care about x's to answer this question. So from negative infinity up to what x? 1. And what goes on the 1?
Bracket.
Why bracket?
Because it's equal to.
Because it's allowed to equal. Yeah. That's how all those work. Yeah. So you interpret, there's a lot of ways of interpreting this. Visually, it's where's this under that? If I would have said greater than, it would have been 1 to infinity. Because that's where f of x is above g of x. Yeah?
Really quickly, could we go over 5A, B, C, like the unions and intersections section?
All right. I was going to do that real quick. So the or, is that the nice bouncer or the mean bouncer? Or is the nice bouncer? It lets everybody in, right? Basically, it says if you're this or that, you come in. So for 5A, it's or. The answer to an or question will always be more, right? Or is more. I like that. So is 5 in the first or second set?
No.
First set. Yeah. So 5's in. You with me? So everything's in. You just don't list something twice. So the answer would be 5. What else is in at least one of them? 11. What else is in at least one of them? 13. You don't say 13 again. What else? 19. What else? 39. What else? 41. All right. See, or is basically, you just got to be in one of these two sets. Just like the nice bouncer. You got to be rich. No. Or you got to know Joe. I know Joe. So I just got to be one of those things. I could be more of them, but I just got to be at least one of them. And then I'm in.
So what do we write for that?
That's it, what we just said.
Just list those numbers? Or
Yep, totally. So, what was it, 5A? It would be 5, 11, 19, whatever the hell else. 13 I left. 39, and 41. Yeah.
When would it not be included if it's a duplicate, then you just write it once?
Yeah.
And for B is the and.
Yeah, totally. So, did you have a question about that one? Oh, sir. So, B is the and. That's the mean bouncer. So, they say, you got to know Joe. I know Joe. And you got to be rich. Yeah, I teach him rich. So, you guys with it? So, and it's going to be less. So, and it says you got to be in the first set and the second set. What's in the first set and the second set for 5B?
C.
That's it, right? That's the only one that's in both. And that's what and means. This and this. You got to be in both.
So just write C, C?
No, C.
And then quote bracket.
Yep. Right? It's sort of like saying who's a Republican and likes to eat broccoli. Joe and Joe. You already said Joe. Is that the bartender? I know. Right? You wouldn't ever say it twice. You're like, you already said that. Are you feeling all right? Yeah.
So what about C then?
Ah, I like it. There's nothing in both. So what's the official answer to that? Somebody remember? What's the symbol for a set that has nothing in it?
Circle with a
Yes,
password?
empty set. Or you could even just put empty set. All right, this represents an empty set, and this is an empty set. So either one. If you said like no solution, I'd be okay with it, but the answer's got to be a set of numbers that does what it asks. So it'd be a set that's empty. It's like another way to say no solution, right? Here's a set of all the answers. All right. Sorry, think about it. Empty bucket. Here's all the yes I give. None.
For
Yes.
8.1, number 105, is that where we do greater or equal to 0?
Yes, totally.
And
The
then
inside.
Solve.
And then solve it.
Correct.
Yeah. So let me ask you this. One of the answers to this question, or these questions I'm about to put up here, is all real numbers. Which one is it?
C,
Yeah, why?
because it's an odd.
It's an odd root. Odd roots are cool with negatives and positives, which is everything. And 0. These guys can only handle positive or 0 input, right? So how would you figure out this guy? So this guy's domain is all reals, just because he's an odd root. What's the 7th root of -1? What do you multiply by itself 7 times to get -1? -1. 6th root of -1. The only thing it could be is -1, but 6 -1s make a positive, don't they? 6 negatives all cancel. Oh, what's up? Sorry.
I know, another question.
Oh, okay. How would I find this guy's domain? What's got to be true about this?
X equals 0 or greater than.
Yes, it's got to be at least 0. Because again, why does that make sense? Because the inside of an even root can't be negative. So what must it be then? The opposite. It's got to be bigger or equal to 0. That's the opposite of negative. So all we're saying here is this must do this. Therefore, what does x have to do? Well, how do we do that? We solve. We always solve to see what x has to do. What makes this true? Any x's that are bigger than or equal to 7. A real quick way to check this is pick something that's not that. Like 6. What's 6 minus 7? Ah, shit. See a 4, 3, -1 you can't do. Oh, good. Then it kind of makes sense. That seems like it probably is right.
So with 9C, it has an odd root that is like, there's a fraction.
Ooh, yeah. That's my, ooh, yeah. You ready? You do the same thing on B, right? Bx greater equal to 5. Same way? 9C on the practice test. Pay really close attention to this bad boy. So it is a 7th root. So does the root have a problem?
No.
The root has no problem. But is there a problem somewhere else?
Yeah, there's a fraction.
There you go. So what can x not be?
6.
6. The bottom can't be 0. Therefore, x can't be 6.
That's
If-
the answer.
Yeah. Was that because of the root? No, the root's cool. The root says everybody works for me. But the inside, there's an x value that makes it undefined. Well, I didn't have to consider that here. Because there's no bottom. There's not a fraction. I can't make it undefined.
So then for 9B, the number would just be all real numbers?
All real numbers. Totally. Because the inside has no problem and the root has no problem. Here, the root had no problem. Ah, the inside's got a problem. Shit, we better throw that out.
So how do you graph after you solve?
Oh, okay. So for like 11?
Yeah, 11, 8.
So the reason why it's a good idea to find the domain of something before you graph it is so that you know what numbers to put in. So if you look at 11a, how do you find this guy's domain?
Greater than.
All right, the inside's got to be at least 0 in order to stay real. We haven't talked about non-real numbers yet. Sound like little ghost numbers, dead numbers.
It's always greater or equal to 0?
If it's a even root. Again, why? Because I can't do an even root of a negative number and stay real. And we're only dealing with real numbers so far.
So negative 2, x is greater than negative 2, and you just graph that on them. Okay.
No. No.
Less than.
This is what x's I'm allowed to use, right? What happened?
It's a
It's a
4.
4.
You get a
Oh, I
negative
put a 2
4.
for some reason. Oh, I was thinking ahead. So that's got nothing to do with the graph necessarily. These are the x's I'm allowed to. What am I graphing? What is it that I'm asking to be graphing? This. I want to graph this function. What? I'm not going to graph this. That doesn't make any sense. These are the x values this function is allowed to use. So now what can I do? I can make an xy table. What's the lowest x I want to use? Negative 2. We just figured it out. It's got to be at least negative 2. All right, let me use negative 2. What happens when I put a negative 2 in there?
You get 0.
Yeah, negative 2 times 2 is negative 4 plus 4 is 0. That makes sense. It's the lowest x value I can put in because it makes the inside 0. Any lower will make it negative. Now, you could be smart about what you put in there. Do I want to put a negative 1 in here to graph this by hand? What would this be? This would be negative 2 plus 4 is 2. Can you do the square root of 2 easily? No, I don't want to graph that shit. Right? What if I put a 0 in? What happens? 2 times 0 is plus 4 is 4. Square root of 4 is 2. So I can put a 0 in and get a nice thing to graph, right? And can you guys show me what a square root looks like? What does a square root look like? Can you draw it in the air? Square root? What's it look like? No. I mean, the function. If you graph the function. I love you guys. I love you guys. Like a parabola looks like this. You with me? What's the square root look like?
Half of the parabola.
Half of a parabola that fell over. So it's this. Right? The more you know the form of a function, the less points you need. If you're not sure, you better do one more point. Bless you. Can somebody come up with another good input? That comes 8. Square root of 8 is not nice.
4.
Yeah, I love it. All right, put a little thought into it. What am I trying to make happen with this? I want it to come out to be like 9. I can't make this become 9 easy. 16, right? How can I make this 16? If 8 is 6, because that would be 12 plus 4. Oh, so if x is 6, 2 times 6 is 12 plus 4 is 16. What's the square root of 16? 4. All right, now if I graph this thing, was that wasn't hard to do, was it? You're just not used to thinking that way. You don't just blindly throw shit in there, because I can't graph the square root of 7 by hand easily, right? Graph it now. I don't know what that. I want some nice whole numbers, so you got to put a little thought into what x's will make the answer come out nice, because I'm doing this by hand. So now you can pick your scale. So probably, for what I gave you on your sheet, you're going to want to do this by 2s. So negative 2, 0, 0, 2, and then 6, 4. So there you can see the shape. Looks like a parabola that fell over and its bottom half fell out.
So for 11b, since it's an odd root, it can be anything.
Anything. And then you just pick, for example, what x would I pick to make the inside negative 8? Because that's a cube rootable number. How do I make the inside on 11b negative 8? Negative 6. So then I put a negative 6 in. See, why did I start with negative 2 here? Because the domain starts at negative 2. 11b, the domain is all real numbers because it's odd root. So then I just start thinking, what numbers make the inside nice? Like -8, -1, 0, 1, +8. You don't want to use the same scale. So I want you guys to start thinking, especially if you got to take pre-calculus. Pre-calculus has got a ton of graphing. And you got a good teacher, a ton of graphing by hand. Because the more you graph by hand, the more you're related to it instead of some little magic box doing it all for you. And then when you take my calculus, you know what the hell's going on. Okay. Anything more about that, or you guys all right? So, what happened? All right, let's see. Oh, Ed, yes. 8? 8G? Okay. The one piece of HE that's sort of an oddball is the number. Do you guys see what I mean? What do you do with the other things? What do you do when you have something to a power raised to a power? What do you do with the powers? Multiply. So those two are nice. The number's not hard, really. The first step, so what was it? 8. Y to the -3. So this is what you do. What's being raised to the -2/3? All of this stuff, right? So I'm going to put 8 to the -2/3, and then I'll worry about it next. So a lot of times you guys try to do too much at once. And then I got x to the 2/5 times -2/3, y to the -3. See how this is what's called being nice to yourself? Right? Write down what you need to do. Don't do it as you're writing it down. Unless you can. So what will this middle thing become? Let's do this first.
-4/15.
Yeah, -4/15. What happens here?
It's over 1, so it's positive.
Yeah, the negatives cancel, the 3's cancel.
2. You just slap the x, the 8 on, right?
Now be careful. How do I interpret this?
Oh, because it is.
It's a negative power. What does that mean? Flip it. There's a 3 on the bottom. What does that mean? There's a 3 on the bottom of the power. What does that mean?
Thirds.
How do you write square root of x? X to the 1/2. How do you rewrite cube root of x? X to the 1/3. Okay, what's the 3 mean on the bottom? Cube root. Cube root of 8 squared.
So we'd only flip it the whole number,
Yeah, what's being raised to a negative power?
the 8,
8.
but you didn't.
You wouldn't flip the 3 over 2. It's not being raised to a negative power. It is a negative number.
So for like the x, like you just will keep it as.
No, the next step would be to bring this down.
Oh, with
I just didn't know. See how this one became positive?
Yeah.
So I do this first, and then I see who's negative. Well, he's negative, so he's going to go down. Next thing I'm going to do with him is bring him down.
Alright, so he'll.
And he's going to stay up top.
Okay.
Going to have the top to himself. So again, we know this property here. You multiply powers. They're fractions, so you just multiply them across, right? You cancel when you can. 8 to that, you have to know how to interpret that. The bottom is the root, like most plants, and the top is power. This is powerful.
So the x would be 1 over the 15 root x to the 4.
Don't bring roots in. You don't have to. We only brought roots in here because we're not used to fractional powers. So that y squared's up top. That goes down below. Right? See that? Those 4/15 x's go down because it's the negative power. This is on the bottom. So what's the cube root of 8?
2.
Squared? Yeah. So again, I don't know if you guys noticed, I worried about the number, I worried about the x's, I worried about the y's. I think a lot of times you guys try to do it all at once, which is crazy.
So how come we didn't turn the -4/15 into a radical?
Oh, because I didn't have to. In fact, how did the problem start? That normally tells you what you should put the answer in. Did the problem start with radicals?
Yeah. No.
No. Started with fractional powers, I probably want to end with fractional. Now, if you put that in root form, I'm not going to take points off. But there's no reason, in fact, convention says keep it the way it was given to you. Did I use radicals in the middle? Yes. Because we're not as used to fractional powers as we are to radicals, right? We're still getting in a little trouble with x to the 1/3 is the same thing as a cube root of x, because we're not used to that. It's sort of like converting between inches and centimeters, right? Because we're not used to centimeters.
So when you say for 10A as an alpha, when you...
All right, so 10, I think I told you guys, that's not on this test. We didn't make it as far as I was hoping. We didn't do section 10.4 yet. That's the dividing stuff. That's where rationalizing is. So don't worry about number 10. Yeah?
Is it, so with the 8 and negative 2, there's when you root it, is it because you have a coefficient, or,
I just did 10
A fractional power means radical. It means root. But why does it make sense? Because what does the square root do to something fundamentally? Cuts it in half. So of course it makes sense as a 1/2 power, right? So a 3 on the bottom means a cube root. And then it's being raised to a second power.
and why wasn't, I'm not sorry, why didn't you do that with the x?
The reason I did it on this is because we're more used to radicals, so then I know what to do to the 8.
Oh, okay, gotcha.
This I could put as a root, but it's not going to get me anywhere. It's just x. So there's no real reason to.
Okay,
Yeah.
gotcha.
Fauzi,
Oh, can you do 9C?
I did. I did. What's the look on the inside? So it's a 7th root, so that has no problems, right? It's an odd root, so that would be all real numbers. But the inside has a 1 problem spot. You see it? What value of x can I not use on the inside? It's got a numerator and a denominator. What cannot happen? It's got a top and a bottom, right? It's a fraction. What can't happen? In a fraction, what can't happen? What can you not have on the bottom?
Negative?
What can you not divide by?
Positive? 0.
0. Yeah, you can divide by a negative number all day long, positive all day long. Can't divide by 0, so then what x makes the bottom 0, like Dante said? 6. So x can't be 6. Not because of the root. The root was cool with everything. But the inside freaks out at 6.
For 1D, there's absolute, what do you mean there's absolute?
One, which one?
D.
D, okay.
So there's absolute values on each side.
So we looked at those. So tell me this. If I had the absolute value of 4, what would you put in here to make it a true statement? Yeah, you could put -4. Isn't that a true statement?
Yeah.
Or you could put what inside here? 4. Of course, that would be a true statement, right? Both of those are true. So one case, so if I have the absolute value of 4n minus 5 equals the absolute value of 11. One case is that equals that. If that number is that number, then obviously the absolute values are equal to each other, right? So one case would be this equals this. Now what else could happen? The two numbers could be opposite signs. So then, or this number is the opposite of this number. Like 5 equals -5. Well, not like 5 equals -5, but this number could be the opposite of that number, right?
And then you just solve.
Then you solve each case. So those are the exact same cases as before. So there's really nothing different when both sides have an absolute value. You do the same two cases. What's a little weird, though, is you have this negative that has to distribute that you don't want to forget. So here you should get one answer.
No.
What?
I was going to say 2, but...
No, that sounds right.
Yeah, it is 2.
Yeah, 2. You got it. Yeah.
Can we break it down? Because I haven't actually know how to, or
Are you cool with this?
I'm
Oh,
cool
no.
with that, but as
Oh.
I'm finishing it off, I have to.
So now this is just an equation, right? So add 4m, add 4m, add 5, right? It's just an equation.
Okay, gotcha.
Divide by 8. And then over here, same thing. You distribute the negative. See how the 4m's are going to cancel? So then that's a weird situation. This contributes no answer, but there's not no solution. There is a solution. There's this one. What does this contribute? Nothing. So that's the only answer.
Gotcha.
Cool. So once you break down the cases, then they're just little equations to solve. Nothing special just because they started here. Oh, no. No liquid. Yes?
8I.
Oh, so what do you do with powers when you divide like bases? So if I had like, if I multiply like bases, what do I do with the powers? You add them, and when I divide, I subtract, right? So on that one, they happen to be fractions. I still subtract them. The process doesn't give a shit they're fractions. But how do I subtract fractions? I need LCD. Right? So they're like bases dividing, so I know I subtract the powers. The powers happen to be fractions, so I need LCD.
The same thing with H.
Yeah, so now you multiply, so you add them. Still need LCD. I like it. Oh, okay. So remember, what would this be here? Square root of 15, I like it, right? Because they have the same root. So I'm going to catch up to you in a minute. Hold on. So what about this here?
Is it 5 times 9?
No. Square root of 5 is not equal to 5. This won't never become 9. Do they have the same root? No. No, so you can't do it. That's simple. If they have the same root, you're allowed to put them under one root. If these don't have the same root, they can't agree. So you can't put them together. So what do you think about this? Why are you allowed to divide? Because they have the same root. Square root of 4 is 2. So on 8f, the first thing you do is reduce. Why are you allowed to do that? Because they are both under a square root. So really, to show you what's really going on there, like this problem here, what I really did on this problem was I made one big ass square root. And then I can just simplify the inside, right? So that's why it has to be the same root. That's the square root, that's the square root. I can make one big ass square root and just say everything's being square rooted. If that was a cube root, couldn't do that. So that's exactly what you do in 8f. They're both square roots. You can make one big ass square root, simplify the inside, and then maybe it can go further. Now, with that in mind, here's one of my favorite questions to ask. You ready? Do they have the same root? But you can do something. Because they do have the same base. So remember what Jeff said about the suckiest way to write these things is in radical form. Radical form is like the least useful way to write these. You only think it's useful because you're the most used to it. If I rewrite this,
X1 over 2.
x to the 1/2 over,
X
at what goes on the bottom?
3.
3, because that's the root.
2 over 2.
Now it looks like another problem we just had a minute ago, right? It didn't look like it here, but now I say, oh, I am dividing like bases, I have to subtract the powers. Do you see what I mean? This is kind of what started me to think, I wish we never invented this stupid radical notation. I hope you don't take that wrong. Some of you guys are like, yeah, math is dumb. I'm not saying that. I'm just saying this is a bad choice. Right? They were high that day, I don't know what.
What about 8E?
Oh, that one is another one that's technically not going to be on there. If I did put something like that on there, you could write this like b to the 14/5. There is something you can do. We just haven't done it yet. I want to. Well, let me show you. Let me see if you get this. How do you do this? Square root of 50. You could do something to it, right? There's a piece I can do the square root of above, and then the other shit, right? And then I do the part I can, and I leave the part I can't. Wow. It's like the Serenity Prayer. So I guess so this one, if only that was what number less than 14? What was the fifth root? What's it able to do? You're going to break it into 5 parts, so 14 sucks. Which number under 14 that would be better? What does 5 go into? 10, under 14. So I can rewrite this as fifth root of b 10 times what's left over? 4. There you go. What's the fifth root of b 10? B squared. What's this? I don't freaking know. It's not enough b's inside. Same idea. It's just that we haven't done many of these with the letters, so I probably would put that on there. But I just want to show you, it's the same idea. What's really cool, watch this, you ready? 5 goes into 14 twice with 4 left. Next room gets to get my Morse code. Do you guys see? 5 goes into 14 twice with 4 left inside. I mean, so the way we've said it forever actually works beautifully for a shortcut on these things. We'll do more of those after this test. Yes? Oh yeah, okay. So 2b, it's got a negative on the other side, but it's definitely not one you can just stop and say no solution or something. For 2 reasons. It's an inequality, and what have you not done yet at the beginning that you need to do?
Gotten the absolute value by itself.
Yes, you must isolate the absolute value. So what's the first? Now be careful, dear God. I'm not going to put a negative 2 here, right? What is that related to? Please excuse my dumbass son. Or dear son. Right? This is 5 times this. This is 3 minus. No, so minus can't be done before times. So how do I start to unearth this thing? What's the first thing I can move? The 3. I can subtract 3. And then I can divide by negative 5. Now I see what kind of problem this is. Right? It's a less than problem. So you can't make any assumptions until you get that absolute value by itself. And then how do I rewrite this? So less than. It's a sandwich. It's to stay close to me, right? Less than. Distance less. So this can go up to 3 and down to negative 3. There you go. And then you just solve that. Subtract 10, divide by negative 7. So when you divide by negative 7, the sign's better. Flip. Yeah. You guys like that problem. But the idea is get the absolute value by itself first, because otherwise you don't know what the hell to do yet.
Could you have distributed the negative 5 into the...
Definitely not.
No?
Because how do I say this? Normally you definitely don't take negatives and positives inside of an absolute value. Because for a couple reasons. Would this become 3 plus the answer or 3 minus the answer? Right? And the absolute value, so if I have like 7 minus 7x, I can take a 7 out. But I can't take a negative 7 out because the absolute value of negative 7 is 7. See how there's some ambiguity there. So you can't put a number back in because it's like, well, what is it really? Is it negative, positive when it's in there? I don't know. So you really don't want to put constants back in. Now, all day long, I can do this. Because that's positive 7. But the minute it's negative 7, and thinking about putting it back in, it gets really wonky. So I just say in general, don't bring constants in to absolute value. Don't distribute. Okay.
So, for 7, we simplify the following using real numbers. You just want us to make it into fractional.
No. Just do it. Like the 7a is just straight up no work to be shown, really. Right? For example, what's 7a? 9. 7b is the same exact idea, just got some more parts. So what's the cube root of 27? 3. What's the cube root of b to the 6th? I mean, x to the 6th? X squared. 3, right? Cube root. Y to the 9th? That one's 3, yeah. Because again, what's the cube root do to something? Cuts it in thirds. Right?
So basically, what you did on the board, you just skipped the step where you put the 6 over 3 and then 9 over 3.
Sure.
And then you just simplify it.
Yeah, because we know by now that if I ask you for the square root of x to the 20th, that's just going to be what? And let's see, what, x to the what now? No. What's the square root do to something? Cuts it in half. Cut it in half. X to the 10th. And you want to see really why that is? How do I rewrite something square rooted? It's that thing to the, and that's the 1/2 times 20 you're talking about. Yes. So if you really want to see it in your face, then that's why it's half of that, because it is half of that. So cube root would be 1/3 of that, and so forth. But be real careful. Don't tell me that the cube root of 27 is 9. That's 27 divided by 3. The cube root of 27 is 1/3 of it multiplicatively. And that's 3 times 3 times 3, so that's 3, right?
For 7D, I know it's x plus 6 squared, but would you write it at the absolute value
Yes.
of x, y?
Because x plus 6 could be negative. Yeah, so if I have, the y is this,
What was the problem?
y is this is 7c, d. Why is this not equal to this? This is not true. And you're like, that's my question. What if x is negative 7? What kind of number is this if x is negative 7? This is a negative number. Can the output of the square root be negative?
No.
Hell no. Right? So we don't do this to make it positive. We do that because it has to be positive. I want you to realize. So let's try it now. Let's see if this is true. If x is negative 7, what do I get in here? I get square root of negative 7 plus 6 squared. What's negative 7 plus 6? See, if I let x be negative 7, I get negative 1. What's negative 1 squared? 1. What's the square root of 1? 1. And now if I put x equal negative 7, that's the absolute value of negative 7 plus 6. That's the absolute value of negative 1, which is 1. So it's true now.
You just drop the squared part on the x plus 6? When you,
Wow. All right. Help me out. What's the square root of x squared? X. Did you drop the 2? No, you took half of it. Yeah. So what's the square root of something squared? That thing to the first power. Why the absolute values? Because it could have been negative, and we got to show people, no, we mean the positive answer. It's got to be the positive answer. Yes.
So we'll get marked down if we don't write it.
Absolute values? Yeah, that's huge. Because otherwise you're telling me that you think square roots can come out negative. That's a problem. Why do I not have to put them, so this is absolute value of x. What's the answer to this? Do I need absolute values? No. Because for real numbers, that's always going to be positive or 0. So I don't need them then. If you put them, I'm not going to take points off. I'm just going to say, you don't need this. It's already positive.
so like,
For 7D, would you have to factor that first? Or
Totally. That's where this came from.
Oh, okay.
Yeah.
And is that the same for 7C? We write it with the absolute value?
No, definitely not. What's wrong with 7C?
You have a negative on that.
There's a negative on the inside, so it's not real. I can't do shit. So one is the answer to a square root can't be negative. So that's where absolute values help me. That one can't even start. It's got a negative on the inside. I can't save it. Right? You can ask anything. I know you have questions. You can ask something we already talked about. Somebody already did, and I explained it real quick. Yes?
Can we just do number 4? The graphing one?
Oh, yeah. So what do I have to do to that first inequality? This is a 4. Oh, holy crap. The exact opposite. We'll have to do that first.
Get y.
Get y by itself, because the whole idea here is to graph the line and then shade one side or the other, right? So a lot of people get this problem and they just graph the lines. And I'm like, that's a couple tests ago. The new stuff now is the shading. You leave the shading out, you lose most of the points, because that's the real part of this problem. So if I solve for y, get that. If you don't believe me, do it. All right? You can subtract 3x, divide by negative, so the sign flips, and then these change signs. Is that cool? So then if I go to graph this, what's the y-intercept? Yeah, 0, -1, and then I go up 1, 2, 3, over 1. What kind of line is it?
Dash.
I like it, yes. Make that big. Now which way do I shade? It's really up to you which method you prefer. Greater than, so I'm going to shade up from that line, so this way. Just put a couple of arrows, right? Because I got a whole other line to graph. The other line was less than or equal to 2.
So it's just a horizontal line.
Careful.
Oh, it's a vertical.
Vertical. I like it.
Oh, I messed up.
If only there was I was always thinking about, well, it's vertical because of this, C of the V, but then Y does that shit too, so I don't know. That's a vertical line, X, vertical. So what kind of line is it going to be? Vertical, what kind of line though?
Solid.
Solid. Yeah. And then less than or equal to. So this is really obvious, you're just going to go that way. So where's the answer? It's where those two overlap, right? So I kind of extend this. It's going to be, so it overlaps in here. See that? It's not here. It's on that side of that and on that side of this line. So it's this area here. It's where the shading overlaps. You've got to make it dark to make sure I know you know what the answer is. What does this mean? Every point in this area works in both. So like this point won't work in either one. This point will only work in this one, and blah, blah, blah. Yes?
So number 3 is just one line.
Yeah, yes. 3 is the same thing, just 1. Yeah. So if you could do 4, you could certainly do 3. It's like one less whole problem to do.
No, I just wanted to check if I got this correct. For 1C, the X is the only absolute value. 1C on the practice test.
Sure.
I got X equals -4 and X equals 8.
No.
No.
No. How did you do it?
I can't remember.
So what do you do first on these kind of problems?
So divide by
Isolate the absolute value. So what do you have to do to get this by itself? You first Subtract 5. It looks like it's going to have some trouble in it. What this is,
Negative 2.
then you divide by 2 and you're screwed, right? You don't go further. What's the answer? This is impossible. Absolute value by definition cannot come out negative, so this is screwed. This is why you get the absolute value by itself first, because you don't know what situation you're in otherwise. All right, let me give you that answer key. Maybe that'll spur some questions.
Is there any reason you left this as a top-heavy fraction?
Which one?
Or,
Because there's no reason not to.
Did you make it a mix?
Sure, of course. They're the same number, so nothing wrong with that.
So once you get the absolute value by itself,
Yes.
that's when you can start.
Then you can do the two cases. The inside equals that, the inside equals negative that. Or you don't do shit if that side's negative yet. Try to solve for what?
Like, why negative 3x?
Yes.
So you put 3x on this side,
Solve for
supposed to
what?
be negative.
Oh, you did.
Solve for y. Try. Do it. Solve for y. So if you just subtract 3x, you don't have y yet. You have negative y. So then you have to divide by negative 1, right? So try it. Solve for y. Yeah.
So what chapters is the test one?
It's chapter 8 through 10:3. Yeah. Which I was worried at first wouldn't be enough for a test, but it's plenty, as you can tell. For the practice test, it's plenty.
I couldn't solve. What was that? The response?
Chapter 8 through 10:3. That's what homework is due tomorrow. Chapter 8 through 10:3. So it's 8, 1, 8, 2, 8, 3, 10, 1, 10, 2, 10, 3. Or we did chapter 9 before already, so don't. What's up?
No, I'm talking to myself.
Oh, okay. I thought I heard you say that's not math. Is that what you said?
No.
Oh, okay.
I said, I don't think that's going to happen.
Aw. Well, again, if you're behind in homework, you start to do some out of each section. You don't want entire sections not looked at, because then you're definitely going to die on those questions. Yeah.
So when you said about taking next semester, you said it's better to take one math 170.
Yeah, if you have to take statistics and something else, it's almost always better to do the and something else first if you're not going to do them in the same semester. Because statistics, there is very little algebra in it. Doesn't mean it's an easy course, but it's just that it doesn't use a lot of algebra. It uses a lot of concepts, but not a lot of algebraic manipulation stuff. Pre-calculus, 175, 176, that's nothing but solving equations and doing all that stuff, right? So you don't want to have a semester of something with no algebra and then suddenly this crazy algebra-intensive class. You've forgotten everything. It's like, oh my God. So I feel bad when that happens. Yeah.
For 11B, you put all reals and then you still graph it? Like, how did you choose the...
Like I said earlier, you choose the x's that will make the inside a cube rootable number. Like, what can I take the cube root of? Negative. Negative 8. What would I make x so the inside's negative 8? Negative 6. Does that... So if you've got to graph this,
Okay, I see what you're saying.
what can I take the cube root of? I can take the cube root of negative 8, for example. So then what would x be to make this negative 8? Negative 6 minus 2, so negative 6. Then what's the cube root of negative 8?
2.
Almost. Negative 2. And then what's the next thing? So I can do the cube root of negative 8. What's the next number I can take the cube root of?
16.
No, going the other way. I don't want to go more negative. I want to go less negative. So like negative 1. What would I make x so that I get a negative 1 in here? 1. So if I put a 1 in, I get the cube root of negative 1. What's the cube root of negative 1? Negative 1. How about 0? How do I get a 0 in here?
2.
Make x 2. What's the cube root of 0? Freaking 0. I really want you guys to... If I had to make a table of values for this, I'm not going to put 2 in there. I'm going to put 3, 6, 9, 0, negative 3. Why? Because I want to be able to divide it by 3.
How many values do you suggest that we make on the table?
The less sure you are about the shape, the more you should do 4 or 5 points. What's really neat about square roots looks like this. Cube root, this is basically even roots look like that. Odd roots, they didn't lose their bottom half because they could handle negatives. You see that? What's the cube root of negative 8? Negative 2. What's the cube root of negative 1? Negative 1. So odd roots adds in all the negative shit that this guy can't handle. That's why these make sense. Why does this not go back here? Because this is all negative shit. It can't handle negative inputs. It can't have negative outputs. That's why it stops right at 0, 0. Can't go any further. This guy, he can handle negative inputs. He can have negative outputs. That's why that's down here now too. And you see that when you do these and you plot it, you can see the shape. It's kind of cool. You can see the shape on the answer key.
For 7B, how come you just left it at x plus 6 on the answer key? And then we kept going and we got 1.
Oh, because to check it, I made x negative 7 just to check it. Well, that wasn't part of the problem.
Gotcha.
Yeah, that's simplified. And then to show